Good evening, dear colleagues, dear friends. At the beginning of my presentation, I would like to thank organizers of this traditional forum devoted to the studies of the real clinical practice, and personally, I would like to express gratitude to Professor Colbin for this opportunity for traditional
врачей и своей знаменитой книжкой «Очерки по
And in the famous book on clinical pharmacology, he used to write that we live in the century when the surgery becomes more and more safer and the treatment is more and more dangerous. Now COVID-19 came, and actually we felt this thesis as never before. So with the example of using anticoagulants, we definitely saw that in 2020, 2021, due to the fact that this group of treatments was considered as drugs for pathogenetic treatment and for the prevention of very dangerous complications, thrombotic complications of COVID-19, we saw increased sales of these drugs in the Russian Federation. So this is direct anticoagulants. This is Eroxaban, Apixaban, and the Bigatron, which may lead to particular clinical consequences. And this is the data of a chief surgeon of Moscow City, academician Shabunin, who is the lead surgeon in Botkinskaya clinic. And also here, the mortality change, mortality from gastrointestinal bleeds without the increased rate of this complication. So we saw the increased mortality from the baseline level 1.2, 1.3 up to 176 by 2020 and 154 in 2021. Well, partially it is related to the better and wider use of anticoagulants in the outpatient protocols. And this is a very good example, as the doctors, unfortunately, very frequently make mistakes in the dose selection, in the administration, in the prescription and duration of treatment, keeping in mind all functions of the patient, creatinine clearance and renal function. If you administer anticoagulants to atrial fibrillation patients, in every fifth case, doctors deviate from the clinical guidelines and from the labels, although they know them. And in case of deep vein thrombosis, they can deviate in 50% of the cases. So we need technologies that in the real clinical practice could increase the efficacy and the safety. Antithrombotic treatments, and they should be mutually additional. This is use of evidence-based medicine. These are clinical guidelines, and they are designed by specific as professional communities. And according to the law 37, that's the basis of providing medical care. This is an important moment which is associated with the quality of life and improved prognosis of our patients. And the technologies of personalized medicine, and in our country we have the concept of developing of personalized medicine. It's important because in the basis of personalized medicine we have a design of particular biomarkers that reflect individual specificities and pharmacokinetics and pharmacodynamics and physiological processes, and could be substrate for the doctors for the selection of treatments, about the prognosis, whether it's a good responder or bad responder, stratify patients into groups. That's the substrate for the personalization, and biomarkers here that could predict individual processes could be the most perspective. Well, continuing the examples of anticoagulants in the analysis of unfavorable events related to the drugs, this is also our own data plus bleeds. You see, in 1/3 of the cases, there is a situation when there is some deviation from the doctor, well, non-intentional. So they are deviating from the guides, from instructions, etc. But in 2/3 of the cases, it looks like it was correct prescription, although the bleed took place, which is related with the individual sensitivity. And now biomarkers that we talked about before in the concept of personalized medicine. So it helps to count this personalization And the concept of personalized medicine is in the strategic documents in the country, and where it's said that priority for the healthcare, the switch from personalized medicine due to the rational use of drugs, and in the strategy of healthcare development in different so-called multi-pay medicines, 3P, 7P, 10P, whatever you want, but it is still the same. This precision, this personalization, this precision is reached due to these biomarkers. Biomarkers due to the definition which is given by personalized medicine in the concept of 3P development, which was designed by the Ministry of Health back in 2018. And our president back in 2018, in his message, is telling us that to reach active living through the transfer from active medicine to personalized medicine, which is using particular scientific achievements, biomarkers, based on genomic technologies and multi-omics technologies, which are the tools of this specific personalized medicine. And reactive medicine actually is still working in many indications. There are clinical guides for the treatment of arterial hypertension, 5, 6 classes of drugs here. So we start selecting depending on comorbidities and special features. So one combination is not working, then we switch to the other, then we manipulate with doses, and we reach sometime later target levels of systolic and diastolic blood pressure. And now we go to the precision personalized model when we have specific biomarker that we believe that this drug, this combination is working. We administer this treatment or the combination, and it could create particular effect without any adverse reactions. And this is how target levels could be reached for blood pressure and international normalized ratio INR. And biomarkers for personalization, they are the same. So they could predict special and this range, there are no adverse reactions and there is high efficacy. These are biomarkers that reflect and that participate of special enzymatic and transport system in metabolism, and they predict so-called ADME processes. And we're designing these biomarkers and we implement them in the clinical practice. And this is what our teachers were dreaming about, specifically academician Lakin in his famous book, Biotransformation of Drugs, where he used to say that personalization could be approached when we know how to manage the outcome of the drug in the human organism. So these are biomarkers for real clinical practice. We start implementing actively to learn, to study how they work. Well, mainly this is pharmacogenetic and pharmacogenomic biomarkers and also pharmacoepigenomic. And here in the basis there is PCR and methodology, which is getting cheaper from year to year. And pharmacogenomics reflects individual specificity of gene, especially those genes that are participating in pharmacokinetics. And pharmacogenomics, these are circulating microRNA and expression of them related to the biotransformation and the transport of drugs. Pharmacotranscriptomics, these are matrix RNA, where they're synthesized in tissues, and mainly these are tumor stories, personalization, targeted treatment. Pharmacometabolomics, well, here we mainly see HPLC for the measurement of concentration of drugs and metabolites, and also we are approaching another group of biomarkers. This is pharmacobiogenomics, where it is possible to predict antimicrobial effects and other hypolipidemic treatments, anticoagulants, etc., etc. But the let's say the first what we do are genomic biomarkers, although circulating biomarkers are also quite prospective in the real clinical practice. We actually saw that they could predict individual specificity of psychotropic drugs pharmacokinetics, and that's the first article about it here on the right. And here on the left, you can appreciate something what we designed. This is methodology of circulating microRNA selection as candidates for prediction of laboratory resistance to clopidogrel in patients with acute coronary syndrome. And last but not least, our studies, we put it together and we announced that it's perspective to use in real clinical practice some circulating microRNA for the prediction of individual specificity of pharmacokinetics, pharmacodynamics, specificity, and blockers of P2Y12 in patients with ACR and ischemic strokes and obliterating. And another publication about direct oral anticoagulants, also with deep vein thrombosis and for the prevention of thrombotic complications after the prosthesis. We're also trying to design particular biomarkers and models of anti-COVID treatments, inhibitors of RNA polymerase. This is favipiravir, remdesivir, and monopiravir. There are gene candidates, and we're doing associative studies as a task force from the Ministry of Health. And finally, we will get prediction model for the decision making for the most optimal option from the point of clinical economical justification that would be working and will not cause adverse reactions. So we see here that this is hepatotoxicity and nephrotoxicity mainly. But for remdesivir, there is some data that it metabolizes until active metabolites in lungs through carboxyesterase type 2. And here there is some genetic polymorphism of this enzyme that actually explains the existence, especially in some ethnic groups, lots of metabolites. So that means slow metabolism, slow transformation of remdesivir into the active metabolites, and this is slow efficacy. So that's pharmacogenetic atlas. This is distribution of slow metabolism in carboxyesterase 1 in the ethnic groups of the Russian Federation. So you can see the slow metabolites. So the brighter is the color, especially in the Urals and Siberian Far East. We need to take it into consideration in the future for the personalized pharmacotherapy and COVID-19. Well, all over the world, there are great hopes for these technologies of personalized medicine and COVID-19 as well. So you can appreciate the scheme shown here. What we have now, so this is the upper part, this is so random administration of treatments according to the modern guidelines, but nevertheless, the lower part of the slide, this is the future where we have biomarkers, pharmacogenetics, and where we can select drugs on their basis, but we can predict it and increase efficacy and safety of this type of treatment. So these schemes and algorithms are important based on all the studies, mainly in the real practice. And what we are doing, we're building it, algorithms of doses, algorithms of selection of methods of control over the efficacy and safety. First is pharmacogenetic studies and personalization of selection of P2Y12 receptors in ACS patients and ischemic stroke. So, and this is doctoral thesis of Karina Mirzaeva. And the right side here, this is also selection of the personalized selection of psychotropic drugs, neuroleptics in adolescents. With the first psychotic episodes, depending on the pharmacogenetic specificities of the patients and correspondent risk factors of adverse reactions. So such algorithms go through the machine learning, and we do special algorithms of prediction of the efficacy of treatment together with our friends on bioinformatics from the Computer Science High School of Economics, and this is Professor Pavtsova. This is a model of prediction of resistance to clopidogrel with ACS patients, and these are multiple factors here, and also pharmacogenetic factors, which may be used potentially as many other factors, except genetic modified factors, and this is how you can change the fate of this patient and change and model the fate of the drug in terms of efficacy and safety. So these algorithms, these models are made into the system of decision making, and one of the most important here, and more successful design was designed together with our colleagues with Skolkovo and actively implemented in some clinics of Moscow, specifically in the Central Clinical Hospital. The author of this algorithm, systems decision-making, narcology associate professor Dr. Zaostrojan. So this method is not simply designed, this is a system. And in the real practice, in narcology clinic, in Moscow Center, and it was shown that the use of this decision-making system in the narcology patients for psychotropic treatments in psychometric scales increases the efficacy, and by OKU scale reduces the rate of intensity of adverse drug reactions. So there is a validation in the real clinical practice of this algorithm. So this type of studies, algorithms of personalization biomarkers needed for the implementation of the clinical practice should dive deeper in the clinical recommendation, and that's what we are doing. So not only local designers refer to us, but also international. So we need to merge these technologies and professional standards, and which is, let's say, northern light for the employees to understand what technologies to be implemented. And actually, this is how make it for the specialists.
Внедрена трудовая функция, это определение показаний к фармакогенетическому тестированию.
This is indications for the clinical interpretations.
Это путеводная звезда, профстандарт для образователя.
And also this is professional standard for the others in order to understand competences. Because from labor functions, we see competences which are needed to be created in the implementation of professional retraining. So this is the right side of the slide, and the left side here, this is continuous medical education. And these are educational programs for the qualification and events to improve the competences, especially using these new technologies in the real clinical practice. So our algorithm, which I already showed, we're already proud by that. So how we implemented the real practice, these technologies. So this is multi-stage algorithm that includes searching part and associative parts, and part related with the design of the algorithm model and their validation, clinical and economical analysis, and also the system of decision-making and particular educational programs. How our doctors are ready to implement these technologies. Actually, 2 weeks ago in pharmacogenomics, so that's a big review of clinical pharmacologists, GPs, cardiologists, how they're ready to introduce pharmacogenetic testing in the real practice. And more than half of them told us, yes, we're ready to introduce these tests. We understand that they improve the quality of patient management, efficacy, safety, and also the interns and doctors are positive about it. And as a bottleneck here, they see the absence of these tests. And we see not enough knowledge about that. So we work on that. We improve qualification for the portal of continuous medical education, and we have several programs like this. And the academy has all the competences. So we have 4 affiliates. And these are trainings based on personalized and evidence-based data, and very experienced experts, 13 academicians and 34 staff, together with the vices of the Academy of Sciences. And the content here, this is a principle of evidence-based medicine and the principles of personalized medicine with the use of pharmacogenetic technologies. So this is complex product together with Atlas. These are educational products devoted to the in genetic testing with different specialists, not only pharmacologists, but very different specialists, gastroenterologists, oncologists, for the improving prevention, diagnosis, and multifactorial diseases. And here we see we have 17 chairs in one institution. So there's a complex program and interactive things, and definitely knowledge control. And currently we launch this educational project, and it would be extra budget, and we're expecting improving competencies of our doctors in these studies. So here you see the title of the curricula. So mainly this is devoted to how genetic tests are helping to improve management of the patients and multifactorial diseases in different areas. So improve competencies, we use educational diseases, and this is Pharmacogenomic Congress that we carry out once in 2 years. The next one takes in 1 year and a half, but pharmacogenetic schemes traditionally is to be carried out annually. And in March 2023, we're also planning next type of school. So technologies of personalized medicine with a real clinical practice, they're not contradicted, but they're adding on methodology of clinical guidelines implementation. So all that provides best quality care and high efficacy and safety of treatments. So wrapping up my presentation, again, we should learn how to treat, and this treatment should be related. We also should follow doctors all lifelong. Thank you very much for your attention. And these are pictures from the planner of our kids. They were actually providing pictures of our academy to our 90th anniversary 2 years ago. Thank you very much. And I would be happy by mail and by other